Here we are at example 4 from our 1.4 number 2 set of notes. We're asked to determine where this function f of x, which is equal to the square root of x, is in fact continuous. Well, if you were to quickly draw a rough sketch of what this function would look like, not sure what's going on with our color scheme here, but you should see an image that looks something like this. Starts out at 0, because you can throw in that value 0, it has to be larger than or equal to 0, and goes onwards towards positive infinity. So we think, for the moment, that you can start out at 0 and go towards positive infinity. And the goal here is to actually kind of verify why that works. Now, again, we're trying to see if you can include, we're testing to see if you can include 0 or not. Now, again, it's going back to that three-step criteria. So the first one being f of 0. In other words, when you throw in 0 into this function, we see that it came out to be 0. Well, that does in fact exist. And as a result, first criteria is met. Second criteria, the limit as x approaches 0. Notice we're approaching 0 just from the right side. We have nothing to really go off from the left, but that's okay. Again, all you need is one side to include this endpoint or not. Again, we're not talking about continuity in terms of like an entire like left side and right side function. We're just talking about continuity at specifically an endpoint here. And as a result, we have the square root of x. So the limit as x approaches 0 from the right of the square root of x, using that direct evaluation, we see that it comes out to be 0. So that does in fact check out. That limit does exist. And then finally, step 3, just seeing that these guys in fact match. So the limit as x approaches 0 from the right of the square root of x is in fact equal to f of 0. Well, yes, 0 does equal 0, so criteria 3 is met. So the true question here, I mean, the question is determine where it's continuous, but the real main question here is, can you include 0 or not? And the answer to this is yes. And you can verify that even just using one-sided limits. All right. So again, though, that is example 4. This would be our final answer. Again, that is example 4 from our 1.4 number 2 set of notes.